Everyone, today I'm gonna discuss pile foundations. So what is pile foundations? Actually, pile foundation is a part of deep foundation. So what is pile? Pile is a small dia shaft which can be driven or installed into ground, or generally pile is you will always find pile in circular shape, but it may be of square shape, or in case of sheet pile it may be of sheet like having small thickness and length as compared to thickness is great or large. So there are various type of pile foundations which are provided according to need of load transfer, according to the based on the medium of transfer, like type of soil and the depth of hard rock or strip bearing strata which can successfully transfer the load of superstructure. As all of you, I hoping that all of you know that what is the main function of foundation. Like any foundations we provide, the main function of them is to transfer the load from superstructure to the hardened earth strata successfully. So we focus on classification of pile. So pile are classified in the numbers of ways based on different criteria, like the material and compositions, means the material from what pile is made of, and second is the mode of transfer of load, and there are different mechanism or mode through which pile foundation will transfer the load. Then we have to classify them according to that mode, and the method of installations. In this we classified the pile based on the method of installation, like in situ pile, cast in situ, or maybe board, or and when board, then we can board pile through two types, like screwing or by providing impact through hammer. And then functions or actions, not in all cases the pile have to transfer load from column to the hard strata, and as most of the cases foundation have to undergone through compressive load. But in case of pile foundation, sometimes it may be subjected to tensile load, etc. So we will later on discuss that how to classify based on the function or action. And then fifth is the displacement of soil. So let's begin. First is the classification based on material and compositions. So we can divide pile into four categories: and timber piles, in which the material used to make pile is timber, and second is steel pile, and third is concrete pile, and fourth one is the composite pile. Composite pile may be made up of concrete and timber, or may be made up of steel and concrete. But since we have to make bond between two different material, and as we know that concrete is already a heterogeneous material, so in present day scenario the composite piles are later preferable than other one. Then classification based on the mode of transfer of load. Mainly a pile can transfer load by two types, in two way. One is by the skin frictions. When we board or cast a pile in sand, then it will exert some force on adjoining soil, and through the Newton's third law, adjoining soil also put some force on from surrounding area on pile. So if there are proper frictional friction between soil and pile material, then it also tends to transfer load from through skin friction to the adjoining soil. And second is the pile may transfer load through the bearing of end tip, like in case of deep foundation, the same concept of the most of the load transfer to the soil strata is by the bearing action of foundation. And based on it, transfer of mechanism of mode of transfer of load, the pile also further classified into three categories, which is first one is end bearing pile. And end bearing pile, the load transfer through pile tip to a suitable bearing stratum. In case when we have to transfer all the load through the end bearing, then we have to choose the depth of pile we have to board pile to a such depth that we get strata hard enough to having bearing capacity to transfer the load of superstructure successfully. And second is friction pile. It is used to transfer load to a depth in frictional material by means of skin frictions along the surface area of pile. And friction pile is also called floating pile, as they do not reach to hard stratum. In case of fully frictional pile, we do not need to search for hard stratum, as we have to we have to board pile up to a such depth that it can successfully transfer the load of superstructure to the adjoining soil through the surface frictions between pile and adjoining soil. So third one is combined end bearing and friction pile. In that case, the pile can transfer load by both the ways, as discussed above. Like it can transfer by the surface friction and as well as the bearing. Classification based on the method of installation. As per the method of installation, piles are further divided into 5 types, like a driven pile. In case of driven pile, like timber, steel or precast concrete piles may be driven into position either vertically or at an inclination. In that case, the precasted pile of concrete or piles of timbers and steels of suitable length bring to the site conditions, and they driven into the soil through the application through the hammering of by the hammering to one end of pile up to a desirable depth. In case of inclined pile, they also called butter pile or racking pile. Pile hammer and pile driving equipment are used for driving pile, board pile, and cast in situ pile. Only concrete pile can be cast in situ, as we know that we can't set up a whole steel factory nearby to a concrete installation site, or we can't grow a timber in a pile hole or pile pit, but we can do concreting in a pile. In case of cast in situ piles, the all of required depth are digged, and then concrete is poured into that hole, and after hardened up, the further constructions work carried out. Only concrete pile can be cast in situ, as the hole drilled are and filled with the concrete. These are straight board or under-reamed pile with one or more bulb. In case of under-reamed pile is used in case of soil having very low bearing capacity. So the one or more bulbs of concrete are formed of dia more than the dia of concrete pile, and they provide additional bearing capacity to pile. And driven and cast in situ pile. A closed end casing or shell is driven into ground. Later casing is filled with concrete. For example, Frankie piles, jack piles. These are piles driven into soil by the means of hydraulic jack. The gradually increased pressure is applied on pile by the means of hydraulic jack, and then pile got bored into soil through the pressure due to the action of pressure. And then fifth one is screwed pile. These piles are screwed into soil by the means of hydraulic jack. Classification based on function or action. On the basis of function or action, piles are divided into 7 categories, like load bearing pile, used to transfer load of structure to a suitable stratum by end bearing or by friction or by both. And B, tension or uplift pile, used to anchor structures subjected to uplift due to hydrostatic pressure or overturning movement due to horizontal force like wind force, etc. Friction get mobilized in downward direction in tension. Actually, frictional force, in case of friction force, as we know in engineering mechanics, have you already maybe you already did that in your mechanics part of physics or engineering mechanics part, that friction is always act to oppose the movement. So if in case of tension pile friction will be act to pull the pile in downward direction, or in case of bearing pile, the friction is act in upward direction. Compaction pile. Compaction pile are the special type of pile they use to compact loose granular soil in order to increase the bearing capacity of soil, and they are not required to carry any load. The material required may be strong. In fact, sand may be used to form pile. Yes, you may in further discussion you may hear about sand pile. So the sand piles are also used to for ground improvement, and these are considered as compaction pile. In case of loose granular soil, these piles are bored through the soil, and so that the loose soil get compacted, and this compaction further enhance their bearing capacity. And fourth one is anchor pile. Anchor pile is used to provide anchorage against horizontal pull from water or sheet piling. Fender pile. Fender pile used to protect waterfront structure against impact of ship and other floating objects, and mostly these are made up of timber. Sheet pile. Sheet pile used as bulkhead or cutoff to reduce seepage and uplift in hydraulic structures like hydraulic dam, etc. But wetter pile. Wetter pile used to resist horizontal and inclined force, especially in waterfront structure. In this figure you can see the tensile pile, compressive pile, or In same structure we can use tensile pile or compressive pile, like in case of tall building subjected to wind load, the windward direction pile in windward direction may be subjected to tensile force, and pile in leeward direction may be subjected to compressive force. So these two type of piles can be used in single structure. And the pile driven at angle are maybe of butter pile, maybe of what we read fender pile or anchor pile, etc. Classification based on displacement of soil. It has been observed that the best way of classification on the basis of effect of installation on the soil, according to we have what the effect of installation of piles on the soil medium in which they are installed. Basis on this, they are further classified into two types. One is displacement pile and another one is non-displacement pile. If during installation a large volume of soil is displaced laterally upward is called displacement pile. In loose sand such as pile densified the sand up to a distance of 3.5 times the diameter of in case of loose sand, pile densified the sand up to the distance of 3.5 times of diameter of pile measured from the center of the pile. This compaction leads to the increase in shearing resistance within the zone of influence. Like you can see in this figure. In case of clay, large displacement pile removed the soil to a distance of 2 into 2 times of pile. During the pile driving, high pore water pressure are set up around the pile. Soil regain its strength only after a period of time when excess pore water pressure has dissipated. Since the increase in pore, we can understand this by the fact that as the pore water pressure get increased, the effective stress on adjoining soil also gets reduced. So due to the excess pore water pressure, just after the installation of pile, the soil may lose some amount of bearing strength or shearing resistance, but after some time when the excess pore water get dissipated, the soil regains the strength, shearing strength or bearing strength more than the previous one. Driving piles are preferred in loose to medium sand and are less preferred in case of clay and dense sand. Example of large displacement piles are driven cast in situ piles, driven pre-stressed piles, steel piles and timber piles, etc. Rolled steel sections pile, screwed piles and open-ended hollow sections piles are the example of small displacement pile. Small displacement piles are used when ground displacement and ground disturbances are to be minimized. Non-displacement pile. Non-displacement of piles are those piles during the installation there will be no displacement in soil medium. In such piles, voids are formed in soils by boring or excavations, and then these voids are filled with concrete. The sides of void can be supported either permanently or by casting temporarily by using bentonite slurry. Bentonite is a type of clay which is having quite high swelling properties and shrinkage properties. Non-displacement pile can be further classified as board cast in situ and board precast. There is no heaving of ground, no noise and no vibrations in this case. Length of these pile can be easily varied at site, and very long and very large dia pile can be installed. Enlarged end up to 3 times of pile diameter can be made in case of clays. Construction process enables inspection of excavated soil and is comparison with the soil exploration data during the installation of pile. Soil on the side of borehole softens due to the contact with water used during boring or concreting. It's result in loss of shearing strength, obviously temporarily, because after some time soil will regain its shear strength. There is difficulty in concreting underwater. That is the major drawback of the non-displacement pile. Piles should be casted or installed immediately after boring, because there may be collapse in case of sandy soils. There may be collapse of boreholes, etc. So extra caring should be taken care of while installing piles. Note: driven concrete pile are generally of diameter up to 500 mm, but board pile may